All right, let's do number 7 from the homework. It should look very, very similar to the problems from the notes, the previous videos, but let's do it anyway. The demand function for Alicia's oven mitts is given by Q equals negative 8p plus 80. Q is the number of oven mitts, P is the price in dollars. Find the elasticity of demand when P equals $7.50. We'll do that first. That'll be like our part A. And then will revenue increase? Okay, that'll be our part B. Let's start with part A. So we need elasticity of demand. We need the formula. It is P over Q times dQ dP. Price over quantity times the derivative of quantity with respect to price. So let's find all those out. So our price, they told us that price is $7.50. So our quantity, we need to use the demand function. If we charge this much, how many can we sell? So it's negative 8p plus 80. We can sell 20 oven mitts at this price. Great. Now how does Q change? How does the quantity change with a price change? The derivative of Q with respect to P, using the power rule, right? This is just a line. What is the slope of the line? Because derivative is just slope. The derivative, the slope, is just negative 8. Now we just plug everything in, and that's letter A. E is 7.5. Q is 20. The derivative is negative 8. Plug it in. 7.5 times negative 8 over 20. And you get elasticity of demand is 3. Great. And now it didn't ask us to say this, but I just really want to emphasize it. Oh dear. I don't know what that was. What does this mean? That means at a price of $7.50 per oven mitt, increasing price by 1% would decrease demand by 3%. That's what elasticity of demand means. So increasing price is going to have a big decrease in demand. Big decrease in demand? We don't like that. Let us not increase these price. We need to sell oven mitts for cheaper. I don't know how profitable this business venture is. But that's what letter B wants to say. Will revenue increase if she raises her price? No, it will not, because demand's decreasing by too much. No. It'll decrease. Sad face. That's all there is to this problem. Let me know if you have questions about it. All right, and the last question that I want to look at is actually from the online homework. Suppose the demand for a product is given by this equation. Again, you can use you don't have to use Q's, but I am going to translate this to Q's because I'm very used to dealing with Q's. So Q is negative 7p plus 204. All right. Calculate the elasticity of demand at a price of $15. P is 15. Okay, what does Q have to be? We'll use a calculator. Negative 7 times 15 plus 204. All right, we can sell 99 items at that price. There was a question where I said I was going to forget that it was in thousands, so I circled it. There it is. Did that never come into play? It never came into play, but I did forget it. I told you I'd forget it. But okay, we didn't actually talk about demand in that one anymore. So elasticity of demand is the absolute value of P over Q times dQ dP. We need the derivative. What's the derivative of Q with respect to P? Just negative 7. Plug it all in and we'll get our answer. And just as a general reminder, when you're doing online homework problems, do them the same way that you do paper homework problems. Have a blank sheet of paper, write everything down, be careful, have your work. Your work is really great for if you make a mistake or if you need to ask for help and stuff like that. It's very tempting with online homework to just do things in your head or on your computer and not write things down. It's a bad habit to be in. Not saying it's the end of the world, but if you really want to maximize your math game, write it down like this. I'm trying to lead by example when I can. So 15, -7, and 99. 15 times -7 over 99. Elasticity of demand is about 1.06. I think that's 06 repeating. All right, so let's write that down. Follow the instructions. It says round to 3 decimal places. So that'll be 1.06. Hold on. Sometimes I need to see it. 06, 06, 06 to 3 decimal places. 061. Like so. At what price do you have unit elasticity? Okay. Now, what this is asking about unitary. Okay. We have unitary elasticity when the elasticity of demand is equal to 1. So you can either solve and set this equal to 1, or you can just maximize your revenue. It's up to you. Your choice, however you want to do it. This time, our derivative is just a number. So this time, I think it'll be pretty easy to just solve it. Okay. One more thing I wanted to say. We have an expectation about what the correct price is going to be for letter B. Do we think our answer for letter B should be bigger than or smaller than $15? Well, when we're charging $15, we have this elasticity of demand. When we're charging $15, an increase of price by 1% will decrease by demand by more than 1%. That's going to be bad for us. So we do not want to increase price. But it's kind of close to 1. So we think we should decrease price, but maybe only decrease price by a little bit. Maybe our answer is like $13 or something like that. So when is 1 equal to elasticity of demand? This is P, this is Q, and this is our derivative. Again, you might prefer just to set revenue, like maximize revenue. Usually maximizing revenue is going to be easier for these. But I do want to show what this would look like. So we get -7p all over -7p plus 204 with absolute values. Absolute value equations are pretty tricky to solve, by the way. Okay. Is 204 divisible by 7? I would love it if it were. No. We can't cancel a 7 from everything. So you can't just get rid of the absolute values and make this positive. It doesn't work that way. That's the short answer. The long answer is too long for this video. So to actually solve absolute value equations, this is going to be true when the inside, and you may have seen this before, when the inside is equal to +1, or when the inside is equal to the negative of the other side, right? Because if the inside is +1, we get the absolute value of +1 equals +1. If the inside's -1, we get absolute value of -1 equals +1 still. That's how we solve these equations. Again, I think maximizing revenue traditionally is going to be easier here. But we solve these fraction equations by multiplying by the LCD on both sides. And we solve from there. So when we do that, we get some cancellation and we get -7p equals -7p. plus 204. We add 7p to both sides. And we get 0 equals 204, which you do not need an advanced degree in math to say that's impossible. It's a good thing we had two options, right? We had to solve either one of these equations to get our answer. Well, this is impossible, so let's hope we can solve this one. Multiply this out, negative 7p plus 204. And again, I cannot recommend enough. This is just kind of for fun to show you how it would look. You can just maximize revenue like we've been doing all chapter long. That'll be easier. But I do want to show what this looks like. Negative 7p equals, distribute the negative 1, positive 7p, minus 204. This looks much better. Subtract 7p from both sides. You'll get negative 14p equals negative 204. Divide by negative 14. You get price is 204 over 14, which is about 14.57. Remember when I said that this price should be a little bit smaller than 15 because our elasticity of demand was close to 1? Well, looks like I know what I'm talking about because it is a little less than 15. We were pretty close. So let's read the instructions, make sure we're typing our answer in right. 14.57, round to the nearest penny. Good. See how we did. It'll be embarrassing if I get it wrong. Good. Great. So that's what we've got here. Let me know if you have any questions about this, and good luck. Enjoy the end of chapter 2. Bye-bye.